All right, so perfect. So now that everything is essentially set, let's tackle this data preprocessing phase. So we're going to do this very efficiently. I'm going to go to my data preprocessing template, and I'm going to copy paste each of these code cells, the first ones. So I'm creating a new code cell here, pasting that here. That's for importing the libraries. Then we're going to take care of the second step of data preprocessing, which is importing the data set, creating therefore a new code cell here. And let's first take care of this, the last one, the easy one, splitting the data set into the training set and the test set, and pasting that in a new code cell right here. All right, perfect. And now before we encode the categorical data, let's just make sure to replace what's necessary here in this template. And once again, that's the beauty of the template. We only need to replace one little thing, which is of course the name of the data set here, right? And the name is of course 50 underscore capital S startups.csv. So there we go. Let's do this. 50 underscore startups. Great. And as a reminder, we don't have to change anything here because this automatically selects all the columns except the last one, and therefore all the 4 features here. So that's perfect. And this line of code automatically selects the last column, which means the dependent variable profit. Okay, so once again we tackled data preprocessing in a flashlight, and now we just have this one last tool to add in our data preprocessing phase, which is to encode that state variable here. So to do this, we're going to get our data preprocessing tools, which you have in your part 1 data preprocessing folder, and now we're going to scroll down to find that tool that encodes the categorical data. So remember, we actually have 2 subtools here, if I may say. That first tool that applies one-hot encoding, which is exactly what we want, and that tool that just encodes a binary variable into 0 and 1. And of course, what we need is this one. So I'm just going to copy-paste that piece of code, and then I'm going to paste that right here in a new code cell to encode the categorical data. And now, your turn to think and figure out what we need to do next. Please press pause on this video and figure out what you have to change here in order to indeed apply one-hot encoding on our dataset. I'll give you a hint, you only have one little thing to change and then you'll be good to go. So please press pause. Okay, and now I'm going to give you the solution. So the only thing that you had to change here is that index here. Remember, this corresponds to the index of the column you want to apply one-hot encoding. And in our previous data set, data.csv, well, remember the categorical variable was the first column. That's why we put index 0 here. But for our new data set, the categorical variable is actually the 4th column. But be careful, remember that indexes in Python start from 0, therefore this column has index 0, this one has index 1, this one has index 2, and this one has index 3. And therefore, the index you need to change here is of course 3, right? So this will apply one-hot encoding to the column of index 3 in your dataset, therefore exactly this state column. Perfect. So we're done with the data preprocessing phase. So now we are going to observe the results of what we just built, just in terms of data preprocessing. And therefore, we're going to do several things here. First, we're going to upload the data set into our notebook, right? And to do this, we click this little folder here and then upload. All right, so as usual, my machine learning A to Z folder is on my desktop. So we're going to go inside, make sure to find it on your machine. Then we're going to go to part 2 regression, then section 5 multiple linear regression, then Python. And there we go. That's the data set which we need to open and upload into our notebook. All right, it is uploaded. And now what we're going to do is we're going to run each of these cells that we just made, but I'm going to add a few prints, so that you can really see what we did, how the different matrix of features and dependent variable vector are created and modified along the data preprocessing phase. All right, so first let's start by importing the libraries. That's easy, done. Next step, we import the dataset, and we can now because we have the dataset uploaded in our notebook. So make sure to have it as well. Okay, now the dataset is imported. We have the matrix of features and the dependent variable vector y. Good. And now I'm going to do a print to show you the state of x. What is x exactly at this stage. So I'm going to do print x, and I'm going to run the cell. All right, and let's see what we get. All right, so indeed, we get exactly the same columns as in this dataset with first R&D spend, then administration spend, then marketing spend, and state, right? We can clearly see that we get the same columns here in the same order. All right, so that's the matrix of features, all good. Now, I'm not gonna show you the dependent variable vector because that's obvious, we're gonna get the same profit. But what I wanna show you is what becomes X after we encode the categorical data, you know, and you can actually guess what it will become, but you will see that the 3 columns resulting here from one hot encoding will actually be placed at the beginning. All right, so let's check it out. Let's run the cell to indeed apply encoding categorical data. And now let's create a new code cell in which we're going to print X again, and let's run this cell to see what X becomes. And there you go, exactly as I told you. We have the same 3 first columns here, so that corresponds to R&D spend, that corresponds to administration spend, and that corresponds to marketing spend. But now, instead of having this state column here, we indeed have these 3 new columns at the beginning encoding that state variable. And we can actually see what corresponds to what. You know, if we have a look at our data set, well, the first row has New York as the state, and therefore New York was encoded as 0, 0, and 1. Then let's see, as a second state of the second row, you know, corresponding to the second start, we have California, and therefore California was encoded as 1, 0, and 0. And finally, well, Florida was encoded as 0, 1, and 0. All right, so that's the one hot encoding that happened. And now all good, we have a fully pre-processed data set. And as I told you in part 1, but I'm going to say it again here because this is important, we don't have to apply feature scaling. Why? Because, you know, in the equation of the multiple linear regression, you know, you have this coefficient that is multiplied to each independent variable, you know, each feature, and therefore it doesn't matter that some features have higher values than others because the coefficients will compensate to put everything on the same scale. And therefore, remember this, in multiple linear regression, there is absolutely no need to apply feature scaling. And one last thing I would like to add as well, because I know a lot of you asked this question, do we need to check the assumptions of linear regression? The answer is absolutely not, because I will explain at the end of this part, you know, part 2 regression, that whenever you have a new data set and you want to experiment with some machine learning models to figure out which one leads to the highest accuracy, well, even if your data set doesn't have linear relationships, you can still try a multiple linear regression on it. And if you know your data set doesn't have linear relationships, well, your multiple linear regression model will just perform poorly, and therefore it will get an accuracy lower than the accuracies of your other models. So you will just not select the multiple linear regression model, but you don't have to check the multiple linear regression assumptions. It will just be a waste of time. Really, I will show you at the end how you can so fast and so efficiently try each of the models on your dataset and select very quickly the one that has the highest accuracy. All right, so I just wanted to be clear on that point. Don't worry about the multiple linear regression assumptions. If your dataset has linear relationships, then good. Your multiple linear regression will check the assumptions indeed and will bring to you a high accuracy. And if your dataset doesn't have linear relationships, well, fine. Your multiple linear regression just will perform poorly and you will just take another model. And that's it. That's as simple as that. All right, so now good. We're done with data preprocessing. We can therefore move on to the next step, which is to train the multiple linear regression model on the training set. So take a little break here, and as soon as you're ready to build your next machine learning model, well, join me in the next tutorial to tackle this. And until then, enjoy machine learning.